Okay, guys, we're going to get started. We have a question on number 25. 25 is calculating area of the shape. So we can break it up into a semicircle and a triangle. See that? So here, this distance is given. Some properties of geometry. The chord of a circle, or if I take any distance, if it makes a perpendicular line, then that would be the diameter of the circle. So it's kind of out of the scope of this course, but the radius would be given right here. So you can kind of assume the radius is 3.5 or 3.5. So how would I find the area of a semicircle or half of a circle? 1/2 pi r squared, right? So here the radius is end up with 3.5, and that would be in inches. The tick marks, 2 tick marks is inches. 1 tick mark would be a foot. So sometimes things can be written as 3 feet, 2 inches. Everything in here is in inches, so we don't have to do any kind of conversions. What would be the area of the triangle? 1/2 base times height. So what would be our base? 7. All right, 3.5 plus 3.5. And our height would equal 2. Here we could say vertical angles are congruent, so all those are 90 degrees. But if I plug, using these formulas, if I plug that into a calculator, 1/2 times 3.14, if you're using the pi button in your calculator, your answer might be a little off from the one in the back of the book, because it wants you to use 3.14 to be consistent. Times 3.5 squared, 1/2, 7 times 2, this is 7.5. I do 3.5 times 3.5 times 3.14, then divide that by 2, 19.2325. Assuming I hit the right sequence of buttons in this calculator. If I add that together, oops, I get 26.7325. And then inches squared, probably right, inches squared. And I don't know what the back of the book says here. Do they round 1 decimal, 2 decimals? 26.2 in the book. Let me go back. Does it say anything about pi? Find the area of the irregular shape.
Ms. Van,
Yes.
what is the slash marks that you have there?
The 2 slash marks?
Yeah.
Those are the units. 2 slash marks are inches.
No. Okay.
Oh, this long line?
Yeah.
That's used in some notation. If you have a formula and you put this line, these are your variables. So I'm plugging my variables into my formula.
Okay, so you're just, okay, gotcha.
You see that a lot in like a calculus course. You would say, this is the function, then I'm going to evaluate it. Some calculators have a bar like this. And if you put in a function of x and you put that bar and then say x equals 5, it will plug 5 into that function. And then you can take that same formula and then change x to be 3 and it'll plug 3 into the function. So a shortcut.
I didn't know we were taking calculus.
Well, I mean, you see it in calculus. It's the application can be applied anywhere. Let me see here. What? I can plug this in.
So is this the same exact thing we'll get for the?
That's the same exact thing you'll get for the test. So this is third edition of the book. We're looking for chapter 10, 10.4 or 10.5? 10.4. 10.4. 10.4, number 25. Let's see, 10.4, number 25. Oh, it's 7, not 7.5. 14 over 2 is 7, not 7.5. Right, this is not 7.5. It's just 7. The 2's would cancel and you'd have 7. And then what's 19.2325 plus 7? And that would be 26.2325 inches squared. And then if you round that to 1 decimal, yeah, 14 over 2 is not 7.5, just 7. Does that make sense?
Yeah.
The answer there. Any other questions on homework?
10.5,
10.5?
numbers 25 and 29.
25 and 29. 25 and 29. So let's grab the picture from 25. Oh. Exercise 11.
48 and it's for 25 actually.
Copy. So for 25,
I don't think we went over 25 and 29, like,
surface area?
yeah.
Yeah, so you have to break it up. What is the surface area of a square? The base is a square, right? So what is the surface area of a square? Just the area of a square, which is, yeah, length times width. Yeah, so this would be 6 meters times 6 meters, which is 36 meters squared, right? That gives you the area of the base. Now, I have 4 triangles here, right? I have a triangle here, triangle here. I have 4 equal triangles. So I have 4 triangles. So if I find the area of one triangle, I can add up the area of, I can take that times 4 and add that to the area of the base and I get surface area. Right? The height of the triangle, in this case, is going to be the lateral surface area, or the lateral height, L. Right? The height here is the distance. If I take any triangle and I take a perpendicular bisector of one of the sides, this gives me the height of that triangle. Right? This is the height of the pyramid, which is different than the height of the triangle. If I was to take that side off and move it around in space, the area is not going to change. So I need to find this distance L. So I need to use Pythagorean theorem here. So this distance would be half of 6, right? The distance of half the base is 3. So I can kind of cut out a triangle here that this is 3 and this is 4 and this is L, the lateral height. The lateral height of the triangle. So I need to calculate L, and L squared is 3 squared plus 4 squared. So L squared is 9 plus 16. So L squared is 25. So L would be 5. If I did the math correctly there, you see that? So now I have a triangle with a base of 6 meters and a height of 5 meters. So how do I find the area of a triangle?
Base times height.
1/2 base
1/2.
times, right? So I have 1/2 6 meters times 5 meters, which is 15 meters squared, but I have 4 of them, right? So I have one base, 36 meters squared. I have 4 triangles, so that's going to end up being 60 meters squared. So that gives me 96 meters squared. This is number 25 on 10.5. 10.5, number 25. 25, and we get 96 square meters. Ignore their notation, it's a little more complicated.
Probably, yeah, I was gonna say it's probably easier just to break it up than to use like
The form
square root or not square root,
formula,
the formula that they give you.
yeah, the formula they give you is a simplification. If I was to put this as A and this is B, and then you just plug it in, it's a lot easier to say, what's the area of a square? I know that. I can find that. So to find the surface area, I need to find the area of all the sides. I could give you a really weird figure, right? I don't know, and tell you the area of this, the area of this, and the area of this. The surface area is just going to be the sum of those areas, right? It's hard to imagine this maybe in 3 dimensions because you have all these, points. You have a 3-dimensional shape. So typically, irregular figures are kind of weird, but any of the given figures, the surface area is still going to be the sum of all the faces. So that was 25. 29, we're looking at 15. So 15 here. So for 29, we're looking for the surface area of this shape. Does the formula give you a surface area of a cone? I think it does. Surface area of a cone? No. So the 10.5 surface area, that's volume.
It gives it to you in the book.
In the book.
How to use it.
Let's see what it has here. Oh, okay.
Is it a right cylinder?
It's not a right cylinder. It's a cone.
E equals 1/3 pi r squared.
That's volume, I think. Oh, no, that wouldn't be pi r squared surface area.
No, it is
No.
volume. It is volume.
Yeah. So surface area here is going to be the area of the base, right? Area of base plus the lateral surface area. If I take a circle and I fold it to a point, let's see what we get. Cylinder with no top, a cone with no bottom. Okay, it's just pi RL. That makes sense. So the surface area of a cone is pi RL. Pi RL, where L is the lateral surface area, or lateral area, right? So you have to go and find L. R is given. So if I make my formula here, R would end up being 8 feet. So I have to drop in this triangle here. This is L, this is 8, and this is 15. So I have to calculate L. L ends up being 8 squared plus 15 squared. L squared is 8 squared plus 15 squared, and so on with the calculator. Want to do that?
289.
289, and the square root of 289?
17.
So L is 17. So L here is 17 feet. So area of the base here would be pi r squared. So I have 3.14 times 8 squared plus 3.14 times 8 times 17. And if I plug that in, what do I get? Anyone? 3.14 times 64 plus 3.14 times 628 point what? 31 feet squared. So this was number 25? 29. Oh, here it is, 29. 29, 628.3. 628.3. So our answers are both correct there. So on surface area, you generally have to find a lateral surface area. For volume, you just need the height. So you might need to memorize this surface area for a right circular cone, or in this case, just a cone here, is pi r squared plus pi r L, and L is the lateral height. So you'll have to break that down and find it. In some cases, they might give you a right circular cone and ask you for the volume and give you a lateral height. You would have to do the same thing if this was R. You would have to use Pythagorean theorem to find H. Any other questions on the homework? Homework will be due a week from today. So we should get through most of 10.3 today. And so you should be able to work on your homework, and we'll have time in class on Friday to probably work on homework type problems. So if you want to bring your book and work on that after the lecture on 10.6. If we get all the way through lecture 10.6 today, which is a possibility, I'll just have Friday as a work day, and it's optional if you want to come, so I won't count you absent if you're not here, but I'll let you guys just work on homework, and I'll just be floating around to answer any questions for that. So, or pull them up on the board and go over them together. But it'll be so you can get all your homework in, and then we'll come back and review. We might have 2 days for a review. If that happens, we'll start preparing you to review for the final. Chapter 10 in general is pretty easy section, which is nice to kind of end the semester on an easy note. Today we're going to talk about right triangle trigonometry, which I think is about 12 to 25% of the MOGIA. Do you know sine, cosine, tangent? Do you know these ratios? So we're going to talk about finding basic trigonometric ratios. Use those ratios to find a side of a right triangle. Use the ratios to find angles of a right triangle. So on top of it, now we're going to be able, given the sides, we're going to be able to talk about what the angle is. And then solve problems using the trigonometric ratios. So these ratios is the basis of trigonometry. Oh my goodness, I can't talk. The basis of trigonometry. We won't go into what it means to be sine, cosine, and tangent, but their functions. We won't go into the definition of the function, but a lot of times students have a hard time connecting to what is sine? Well, sine is a operation on a number. So you have to have a sign of a number for it to make sense. A lot of time in your calculator, if you push the sine button, it'll give you an open parenthesis and a closed parenthesis. So sine by itself doesn't mean anything. Tangent by itself doesn't mean anything. And cosine by itself doesn't mean anything. You have to plug something into it for it to mean something. The name literally means angle measurement. We use these relationships among the sides of angles and triangles to solve problems. The big restriction we'll work with when studying the basics of trigonometry is angles have to be right angles. So if you took a trig course, which is a full, I think it's 2 credit hours, semester of coursework, you go into different types of triangles. But for this course, we're only going to look at right triangles, right? So one of the angles have to be 90 degrees. And then one of the angles being 90 degrees, we have 2 other angles to talk about in a triangle. We have angle A and angle B. Okay? And then we have these side lengths. Typical notation here, and the notation doesn't really matter, but if you can keep the notation straight, it's going to make a little more sense. We call the side opposite of angle A little a, side opposite of angle B little b, and the side opposite of angle C little c, right? So anytime we shift that orientation, we want to keep that straight, because it might say find side A. That's going to be talking about the side opposite to angle A. Side length B will be the side opposite to angle B. You guys see that? And C will always be used to represent the right angle. So later on in the problem statements, it'll say little c is this. Big C will be known to be 90 degrees. Little a is given this, so you'll draw your triangle in that form. So we're going to talk about the 3 basic trigonometric ratios. It turns out there's 6 of them, but we're only going to talk about 3 of them. And we're going to talk about sine, cosine, and tangent. Sine of angle A. If I'm looking at this angle and I take the sine of the angle, then that's going to equal the same ratio as the length of the opposite side over the hypotenuse. How many of you have had experience with sine, cosine, and tangent? Maybe half of you. So you'll want to memorize these 3 ratios. Sine is opposite over hypotenuse. Okay? So if I want to know the sine of this angle, I'm going to plug in sine of A equals A over C. A is the opposite and C is the hypotenuse.
So sine equals opposite over the what?
Hypotenuse.
That's a fun word.
Okay, how many of you have heard of SOHCAHTOA?
SOHCAHTOA.
Yeah.
Yeah. Sine opposite over hypotenuse. Cosine is going to be adjacent. So this is the angle. This side's adjacent to the angle divided by the hypotenuse. So its ratio is B over C. You're a lot better off memorizing the names, adjacent, hypotenuse, opposite, and the ratios than B over C. Because I can take that triangle and make it look any other way than B over C. Adjacent is, so if I was talking about this angle, B, A would be adjacent to B. But I'm talking about this angle A here. So B, lowercase b, is the side that's adjacent to that angle. The hypotenuse is always the one opposite of the 90 degrees.
So hypotenuse is always hypotenuse, but then the adjacent is whatever is next to it, other than.
Yes, and opposite here is what's opposite of it.
Okay.
So why?
But we're going to talk
Well,
about
I
the
mean-
2 different angles.
Why is it not C? I don't understand.
Here, C, because C is the hypotenuse.
Okay.
C is also adjacent to the angle A, but it's the hypotenuse, so you wouldn't
Okay.
It's always-
take that leg.
All right.
So for sine and cosine, it's either opposite over hypotenuse or adjacent over hypotenuse. Tangent is actually opposite over adjacent. right? So tangent of A is A over B, but tangent of B is B over A. Right? If I'm talking about this angle and I say what's tangent of this angle, it's opposite over adjacent. Sine of this angle is opposite over hypotenuse. Cosine of this angle is adjacent over hypotenuse. You guys see how don't try to memorize A or B, because it depends. Don't try to memorize A over B or B over A. Memorize the words here, or remember the words here.
Because they're not always going to be in that order.
Because they're not going to always be in that order, and this only works for angle A. Tangent of B is B over A.
So what if you flip it like where A side is on the bottom, like stand it up?
This
Rotate it.
A,
Yeah, if you
or if
rotate
you
it.
just rotate it and
So
make
would
the
that change
triangle
points?
look like this,
Yeah, would that change?
and
where
we
the
would
A
call
is?
this would be C, this would be A, and this would be B, this would be big A, and this would be big B.
So it would say the same, it'd just be a different way.
Yeah, so if I wanted to know tangent of A, it's still A over B.
What if it flipped the opposite way? Would it change the points then?
No.
Okay.
If you keep the points the same, where A is always going to be, big A is always opposite of little a.
Okay.
Big B is always opposite of little b, and C is always opposite of C. Those are kind of linked together. And if I look at this and I rearrange it space any way, if I'm thinking of sine of A, I'm thinking opposite over hypotenuse. Opposite, the side length opposite of the angle divided by the hypotenuse. If I think of cosine of B, cosine of B is adjacent over hypotenuse. So that's A over C. Cosine of A and sine of B are equivalent, but we won't go that far. There's a lot of formula. I mean, there's pages and pages and pages of trig formulas that are equivalent. We won't go into that. We'll just start here.
This is probably a dumb question. But you find the tangent, sine, or cosine of something, and it will give you the big letter, and you just look at the little letters. Like, say we're going to be a big letter and a big letter.
No,
Right? Okay, that was my question.
but sometimes you get to make your own. I mean,
Right.
they will give you three. So there's 6 things going on here.
So I'm
in
just
triangle.
saying, you're just,
3 angles and
we're
3
just
sides.
looking at the little letter spots.
Right now, if I said, what, we don't know what this angle is, right? It's not measured. But I can tell you what sine of this angle was. If I was to be able to plug it into a calculator, I could tell you what sine was because of the ratio.
Yeah.
Every triangle are going to have the same ratios. No matter if they're really small triangles or huge triangles, the ratio of the angle is going to be the same. So if I have a 30-degree angle, the ratio is going to be the same if I have a tiny triangle or if I have a huge triangle. And that's how trig works. So here is an example of how you're going to apply this in the beginning. For the triangle shown, find sine of B. So we're looking at this angle, right? This angle here. What would be the sine of B?
3 over 15.
So first we need to find C, right? So what would be the hypotenuse C here? C squared is A squared plus B squared.
Plus 9.
So C is 5. And this turns out to be a 3, 4, 5 triangle. It's a common triangle in trig, but you can always apply the Pythagorean theorem and find C. So now that I have C, sine of B, what does sine tell me to do?
Wait, how'd you get 5 over hypotenuse?
16 plus 9 is 25, and the square root of 25 is 5.
Pythagorean theorem.
Pythagorean theorem. So what is sine of B?
Opposite over hypotenuse.
And what is opposite of B?
4.
And what is the hypotenuse?
5.
So this is 4 over 5. Another thing to notice, the units cancel out. So sine of an angle is actually unitless. It's a ratio, right? So it doesn't matter if you're taking inches over inches or feet over feet, the ratio is going to be the same. But you need to make sure you're taking feet over feet and not feet over inches. So what would be cosine of B? 3 over 5, right? I'm looking at my angle B. The the side adjacent to B is 3, and the hypotenuse is 5. What is tangent of B? Opposite over adjacent, which is 4 over 3. You guys see that? So just for fun, let's do what is sine of A?
Five over 4.
So I'm looking at this angle A. You see how I look at the angle A? I know what sine is. Sine is opposite over hypotenuse. What is opposite of angle A? 3. What is the hypotenuse? 5. So 3/5. What is cosine of A? 4/5, right? And what is tangent of A? 3/4.
So they just flip places pretty much.
So you can see how if I, what is sine of this triangle doesn't mean anything. You have to have sine of an angle. So I'm looking at the angle, and sine would be whatever's opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Question?
Nope.
So you'll never be asked to find C
No.
because it's 90 degrees.
Yeah. Yeah, C is given as 90 degrees, so it's actually either 1 or 0.
So this only works with right triangles or any?
No, it works with
Because if you already have 90 degrees, but
so it's only going to work with right triangles. However, there are things called law of sines and law of cosines you can use in other triangles. But no, this ratio only works in right triangles. This
Okay.
sine over sine, cosine, and tangent ratios only work in right triangle, and you wouldn't not be asked what the sine of a right angle would be. So the first thing we had to do was find the hypotenuse, and we get our 3 answers for sine, cosine, and tangent. Question?
Okay, yeah. The only question I have is like the Pythagorean theorem.
Mm-hmm.
So it's 4 squared plus 3 squared equals C squared.
Mm-hmm.
But technically, I don't have to square them right because it's just going to be 5.
You could memorize a 3, 4, 5 triangle and know it's going to be 5. The reason why it's 5 is because if this is B, this is A, and this is C, if I follow the right naming convention, the Pythagorean theorem states C squared is A squared plus B squared.
Right?
So whatever this distance is going to be 3 squared plus 4 squared, which is 9 plus 16, which is 25.
So C equals 25.
C squared equals 25. So C is the square root of 25, which is 5. Right? If this is B
Is that what
squared,
I
this is
see?
C squared, this is A squared plus B squared is C squared. Oops. A
Is the
squared.
hypotenuse always C?
Yes, the hypotenuse is always C because C is always
And it doesn't
across
matter
from
what
the right
other
angle.
two are.
What?
And it doesn't matter what the other 2 sides are.
It doesn't matter what the other 2 sides are. No. Those are called the legs of the right triangle. The sum of the legs squared is always going to equal the hypotenuse squared. Does anyone have any questions? This is a good thing to memorize. Don't worry too much what the angle is. You just need to know this. If I'm looking at angle A or if I'm looking at angle B, then sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Right? So we're going to look at some very special types of triangles. And the first triangle we look at is a 30, 60, 90 degree triangle. First off, we're just going to look at the 30 part. In every triangle, the ratio of opposite over hypotenuse of a 30-degree angle is always going to be 1/2, 0.5. So if this is 30 degrees, this has to be 60 degrees because we have a triangle. These two angles are going to be complementary because this is 90 degrees. But if we're looking at a 30, 60, 90 degree triangle, and I'm taking the sine of 30, it is always going to be 1/2, 0.5. The ratio, doesn't matter if it's really small or really big, the ratio is going to simplify to 1/2. In this triangle, it's given 3/6. In this triangle, it's 6/12, which is still 1/2. Do you guys see that? So we can use this if we know one side to find the other one by knowing the ratio. We can draw a similar triangle, and it turns out a similar triangle in any of these, if this is 30 degrees and this is 90, 1, 2. So if I compare this triangle to this triangle, if this goes up by a factor of 3, then this is going to go up by a factor of 3, right? This side length times 3 is 3, and this side length times 3 is 6. I could do the same thing to get this a little bit larger triangle. Now my ratio is 6. I take the smaller triangle, multiply it by 6, I get the larger triangle. The angle measurements in similar triangles don't change. I just blow them up. The ratios stay the same. So let's look at an application here. In a right triangle ABC, find the length of sides when A measures 30 degrees and B is 200 feet. So I draw this triangle out. And it doesn't matter the orientation as long as you keep your notation similar. If I call this A, side opposite of that is little a. If I call this B, side opposite of that is little b. Doesn't matter the way I draw it as long as I keep that convention similar in everything I do. So here they say this is 200 feet. And it says the measure of angle A is 30 degrees. What is the measure of A? Oh, wait, sorry. What's it ask? Find the side length of A. The notation is a little different. So I need to come up with the trig function that involves A, B, and 30.
Didn't you just say that A is, or B is
200.
200 and A is half of B though, just a minute ago?
A is not half of B. Sine of 30 would be 1, 2. So C is actually twice of A, right? Sine would be opposite over hypotenuse, but I don't have the hypotenuse. I need to use a trig function that I have one other thing in the ratio, right? So right now, I know that sine of 30 is going to equal 1/2, right? But sine of 30 would be A over C. I don't know what A is and I don't know what C is, so this doesn't help me to find A. So what would cosine? And you can use your calculator on these and we'll get there. So what trig function is involved that's going to involve both A and B? Tangent. So if I said tangent of 30, what would tangent of 30 equal?
Tangent of 30.
So this is my 30 degrees.
157,
Good. A over B, right? And I know B is 200. So I have tangent of 30 is A over 200. How would I solve for A? Yeah, so if I plug A is tangent of 30 times 200. So here we can plug this in our calculator. Make sure you're in degrees mode. If you have a scientific calculator or if you have a graphing calculator, you can be in degrees or radians. Radians is a special type of angle measurement we don't talk about in this class, but is a big part of trig class. So every calculator is a little different. Some calculators you might have to hit 30 and then hit tangent. Some calculators you might have to hit tangent and then 30, close parentheses, and enter. So you should get 115.47 feet.
So 200 tangent, 30 degrees.
Yes. So if you don't get that, your calculator is probably in radian.
What should we get?
I don't know if I have a tangent, but
You should.
if you have a scientific calculator, you do. So here, what do you do?
You should be able
to push tangent 30. You're in degrees. I don't have a tangent, but. What's tangent? Sine of 30, it should give you a half.
Oh, that's the inverse.
So your calculator. So cosine, I got that here, I'm looking for it. So we're looking for tangent. The one I would hit. What probably need to put in.
Well, hit enter and see what happens.
So there's tangent. Oh, tangent of 200.
No, not 200.
So length, tangent, cosine, or whatever, and then the degrees, I assume.
Yeah. I think so.
Strangely, my phone has all those buttons.
Really? I think mine does too. Let me check.
Yeah. So your calculator has different modes.
Yeah, mine does too. That's funny.
So you're
You don't realize it unless you like turn it sideways.
Mhm.
You can change it to radians. If you're in radians, so now you don't really notice it, right? You don't really notice it. And if you hit sine of 30, it should give you a half. But in radians, it doesn't.
Oh.
So one way to test is to put sine of 30. So if I go back and hit degrees and hit sine of 30, it gives you a half.
Okay, that's pretty cool.
So you don't even have to memorize it. You can just use your calculator. Look, sine of 30 is a half. Cosine of 30 is going to be 2. No, it's going to be square root of 3. It's going to be a weird thing. That's gonna, never mind. So in trig, you learn this special triangle for any ratio of 30 degrees is 1 to square root of 3. We don't learn the square root of 3 in this class because you can apply your ratios. You can use your calculator. But in some trig classes, you have to calculate things without a calculator, so you have to know these ratios. Let's go back to, so here you're kind of setting up an algebraic relationship. What's given? Here, you're given opposite. Well, you want to find opposite, and you're given adjacent, and you're given the angle. So you want to use tangent. Sine is not going to help you, and cosine is not going to help you. A long way to go about this is you could use cosine to find C, and use Pythagorean theorem to find A, and that's going to take you a lot more time. You're better off using tangent. So now we have a relationship. We solve for a missing value A. We plug that in, and we get our answer of 115.47 feet. So that tells you the distance of A. From the distance from this point to this point is 115.47 feet. So let's look at another example. So in a right triangle, we want to find C. C is what we're looking for. So we draw our right triangle, C, C. We'll call this A, call this A, call this B, B. We want to find C, so this is what we're looking for. We know the measure of B is 72, and the length of side A is 24 feet. What is going to be my relationship between the side that is adjacent and the hypotenuse to this angle? Not tangent. Tangent would be opposite over hypotenuse, or opposite over adjacent. Cosine. Cosine of 72 degrees is going to equal what? A over C. So cosine of 72 degrees is going to be 24 over C. So now I need to solve for C. So if I multiply both sides by C, I would have C times cosine of 72 degrees equals 24. How would I get C by itself? By?
Cosine times 72.
Yeah, and you can use your calculator to calculate cosine of 72. So C is going to be 24 over cosine of 72, which is 77 point what? 6'7" feet. Do you guys agree with her? Oops. The thing about trig is there's a million different ways to see it. If this was 90 degrees, what angle measurement would this be if this was 72? (18 degrees, right? So using this angle, 18 degrees, if I said sine of 18, that would equal 24, or sine 24 over C, right? Let's see. So what would C equal if it was 24 divided by sine of 18? What do you guys get? What's 24 divided by sine of 18?
77.67.
77.67 feet. So it turns out here, sine of 18 degrees is the same thing as cosine of 72 degrees. You can plug that in your calculator. What's sine of 18? What's cosine of 72? You get the same thing. Physics, if you take a physics class, this is a big part of physics, these ratios, being able to calculate the side lengths, and it all depends on how you look at your figure and what's given. This is given as 72, but I know this is 18 because I know this is a triangle, and this is 90 degrees, so that some of the angles in the triangle have to add up to 90 degrees. So if I'm just looking at this angle, and I want C, I'm going to use cosine. But if I'm looking at this angle and I want C, I'm going to use sine. And it's going to both give me the correct answer. Right? Typically, we go with what's given. 72 degrees is given. So to do this problem, I'm going to use cosine. But that's not the only way to do it, because I can extrapolate that given that this angle is 72 degrees, the other one is 18, and use sine. So going through, they used cosine, which is expected, and you get 77.67 feet. Right. Ratios can be used to find angles as well, so we can kind of go backwards. If we know the ratio, we can find the angle measurement. So in our calculator, probably close by sine, cosine, and tangent, we have inverse trigonometric functions. You might have to hit the second key, or it might be right above sine, cosine, tangent. They'll have something like sine inverse, cosine inverse, and tangent inverse. We can use this by plugging in the ratio to find the missing angle measurements. Right? So this is an example. Does anyone have any questions on where to find sine inverse, cosine inverse, and tangent inverse on their calculator? You guys
I have no idea where mine.
find that? Okay, so let's set up a problem and then I'll show you how to enter it. So in this triangle, we have to draw the triangle. Let's call this C, we'll call this A, call this B, and B. It is given that C is 25 inches and B is 24 inches. Find the measure of angle B. So what trigonometric ratio could I use that's dealing with opposite and hypotenuse? Sine, right? So if I was to set this up, I say sine of B is going to be what? 24 over 25. Now I don't know this ratio, so I'm going to use my calculator. And what I'm going to plug in my calculator is I'm going to take sine inverse of the ratio, 24 over 25. That's going to give me my angle measurement B. So on your calculator, you want to hit sine inverse of 24 over 25. Did you find your sine inverse button? Yeah, it's right above.
Okay.
So if you, on your calculator, you're going to have to put 24 divided by 25 and then hit second sine inverse of that. And that's the angle measurement.
Oh, wow.
Anyone else? You should get 73.47. How far are we? Yeah, so we're not quite done. So we'll have class Friday. Okay, so we actually have more work to do. Instead of having 2 review days, we'll start here on Monday. So if you want to come to class on Friday, I will still be in here. It won't be mandatory, so the attendance, you won't have to worry about attendance. However, I will go over homework problems from 10.1 through 10.6. If we haven't lectured over it, which we really have lectured over everything, but if we haven't done a specific example, I'll go ahead and still do that. But on Monday, we'll wrap up 10.6.
So we don't have class this Friday?
Yeah, so on next time, so Friday, it's optional. It's only to work on homework. I will be here, but I'm not going to lecture over anything new. Monday, we'll start here.
I have a question. I moved on to the next one,
Okay.
and it says something about how like